World climatic reasons and on vegetation. Vegetation generally do photosynthesis. For photosynthesis, they make the food release oxygen as a byproduct. Release oxygen as a byproduct. Absorb CO2. Through transpiration, they release water vapor as well. That makes the environment cool. Phytoplankton land is ocean people plant is a primary producer which produces food which turns abiotic components into biotic components. Plants take 17 elements from atmosphere. Plants take 17. Plant is a primary food producer which turns a biotic component into a biotic component. Plants take 17 elements from atmosphere which they use for turning abiotic into biotic components. So nutrients that the plants take, macro and the micronutrients. Hi Max. Hi Max. So micronutrients are the nutrients which are required in small quantities, but macronutrients are required in large amounts. So macronutrients, there are 9 macronutrients that are non-mineral, and this can be further divided into non-mineral and mineral nutrients. Photosynthesis, CO2, transpiration, and then biotic component to biotic components, 17 elements. Plants take 17 elements from atmosphere which they use for turning abiotic into biotic. Nutrients that plants take, that's macro and the micronutrients. So macronutrients are divided further into non-mineral, mineral nutrients and 8 so 9 macro and 8 micronutrients, total 17 elements. So plants take 17 elements from atmosphere which they use for turning abiotic into biotic. Nutrients, total 17 elements, 9 macro and 8 micro. 9 macro, 8 micro. Macro can be further divided into mineral and non-mineral nutrients. Non-mineral nutrients are the micronutrients. So non-mineral micronutrients and mineral nutrients. So non-mineral is carbon, hydrogen, oxygen, and mineral is potassium, nitrogen, phosphorus, calcium, magnesium, and micronutrients like boron, copper, iron, fluorine, manganese, molybdenum, zinc, nickel. Hi Sandeep. Macronutrients, micronutrients. Macronutrients total 9 and micro 8, total 7 elements. Other mineral and non-mineral nutrients. Non-mineral nutrients are carbon, hydrogen, oxygen. Mineral are potassium, sodium, nitrogen, primary, and secondary calcium, magnesium, and micronutrients boron, copper, iron, chlorine, manganese, molybdenum, potassium. So plants take CO2 from the atmosphere, H2 water from the ground, of course. So plants take CO2 from the atmosphere, water from the ground. So sunlight again. Once it's CO2 for that much of sunlight is produces photosynthesis. But so CO2 plus H2O is equal to CO2 from the atmosphere and water from the ground. This is photosynthesis. Why chlorophyll is green? I mean, why the leaves of the plants are primarily green color? हाय संदीप. हाँ पता है, मैं कभी कभी लाइव आ जाती हूँ. आई मीन शोइंग माई फेस. Branch CO2 water. This is focusing CO2 plus H2 reaction with chlorophyll. Photosynthesis. Chlorophyll absorbs the sunlight, and that's what explains green color of the leaves. Plants take energy makes glucose. Plants take energy makes glucose, C6H12O6. Plants may battery. It uses sun energy to make chemical bonds and store the energy in the bond. Plants take energy and make glucose. And now CO2, H2O, photosynthesis, sun's energy. So it uses sun's energy to make chemical bonds and store the energy in the bond. Okay. So it uses sun's energy to make the chemical bond, where it store the energy in the bond. Plants convert sunlight into chemical energy. Very good. So plants will convert sunlight into chemical energy. Photovoltaic cells turn solar energy into chemical energy. Similarly, as plants convert sunlight into chemical energy to make their food, and photovoltaic cells turn solar energy into chemical energy, like the energy into chemical energy. Plants convert sunlight into chemical energy. And growing and turn solar into chemical energy. CO2, C6, H2O. CO2 plus H2O6 plus 6O2. C6H12O6 is a monosaccharide, simple sugar. Simple sugars can be taken to the cells directly, and in the cell they could be broken at the energy part. So the monosaccharide is simple sugar. So monosaccharide is a simple sugar. It uses sunlight to make chemical bonds and store the energy in the bond. Plants convert sunlight into chemical energy, photovoltaic and solar energy into chemical energy. Lithium ion batteries. Solar cells can be taken to directly, and in the cell they could be broken and utilize the energy part. We inhale and take oxygen to the cell. In the cell we have O2 plus, of course. Hi Jart, hello. In the cell, we have O2 plus 6 at the presence of O2, the cell releases CO2 plus H2 plus energy. The CO2 and H2O goes to plant back. H2O released by the evaporation and transpiration. Sweating CO2 is released by exhalation. Plant is the only system which traps sunlight from other living beings to utilize and turn them into cells. So plants is the only which traps the sunlight for other living beings to utilize and turn into cells. If plants are not there, then glucose cannot be produced. C6H12 is not easy to store. Plants convert it to, it's a monosaccharide, right? C6H12. Plants convert it to disaccharide or polysaccharide to store. Polysaccharide restores high energy starch. Cellulose. Cellulose is called as polymer. Bacteria called as cellulose is required to Bacteria are called as cellulose. To break down the cellulose are found in the body of rodents. Okay. Plants store starch in the fruits and vegetables. Cellulose is stored in the branches. This starch can be consumed by living beings. Plants are the source of life on the planet. So, what are the other condition that helps in to give other types of that helps to give other types of plant factors which affect vegetation, nutrients, soil, sunlight, temperature, nutrients, soil, cost, nutrients, soil, sunlight, temperature. Equatorial region, rain season, polar region, polar high, equatorial low, subpolar low, and subtropical high. So, what are the different types of climatic zones that occurs in these belts? Equatorial region, ample sunlight, temperature condition, high moisture. C6 asteroid is known as simple source. Simple source can be taken to the cell directly, and in the cell there could be a broken enclosure and checkout. Macronutrients, micronutrients 9, macronutrients 8, mineral, non-mineral, micronutrients 2, 3, 4, 5, 6, 7, 8, okay. 2, 3, 4, 5, 6, 7, 8, 9. Plants take as to water from the soil, CO2 from the atmosphere. So water plus CO2, water plus CO2 from the atmosphere, and chemical, which is the energy of the sun to convert into chemical bond and produces starch, glucose. So the chlorophyll absorbs the sunlight. Plants make battery energy if it uses sun energy to make chemical bonds and store the energy in the bond. So it uses sun's energy to make the chemical bonds and store the energy in the bonds. Plus, Plants convert sunlight into chemical energy. Okay, photovoltaic cell turns solar energy to chemical energy. Okay. C6H4 is a monosaccharide, simple sugar. Um, Simple sugar can be taken to process directly in the cell. They could be broken and utilized in because we inhale and take the oxygen to the cell. In the cell, we have CO2, C6H4. In the presence of O2, the glucose are burned. The cell releases CO2 to the H2 plus energy. The CO2 and H2 goes to plant back. The CO2 and H2 goes to the plant back. H2 is released by evaporation, sweating. CO2 is released by exhalation. Simple sugar can be taken to the cell directly, and in the cell they could be broken and utilized. Okay. We need and take the oxygen to the cell. In the cell, one we have in the cell we have C6H12 also plus CO2. In the presence of oxygen, the glucose is burned. In the presence of oxygen, the cell releases CO2 plus H2 plus energy. The CO2 and H2 goes to plant back. H2 is released by hydrolysis, of course, evaporation and sweating. CO2 is released by exhalation. So H2 is released by evaporation and CO2 is released by exhalation. Plant is the only system which traps the sunlight for other living things to utilize and turn them into cells. If plants don't have glucose can be produced, this rule is not so it was released by exhalation. Plant is the only system which traps the sunlight for other living things to utilize and turn them into cells. The cancer and glucose can be produced. This method is not easy to stop. Plants can be they could be broken and live and not easy. Plants has to convert it to disaccharide, polysaccharide, starch and glucose. Polysaccharide restore high energy. Polysaccharide restore high energy. Cellulose is called as polymer. Cellulose polymer. Bacteria called cellulase is required to break down cellulose. Cellulose are found in the body of the rodents. So cellulose is found in the body of the bacteria called the cellulase is required to break down the cellulose. Plants store starch in the fruits and vegetables. Cellulose is stored in the branches. So plants will store starch in the fruits and vegetables. Of course, and cellulose is stored in the branches. These starch are consumed by the plants are the source of life. So what are the other conditions that helps to give other types of plant factors which affect vegetation? Nutrients, soil moisture, sunlight, temperature. So nutrients, soil moisture, sunlight, temperature. So this is the condition that helps with the other types of plants. Of course, nutrients, soil moisture, astro. Nutrients are required, of course, soil moisture required, sunlight, insulation, temperature, range of survival. So in the ABC variable, there's low temperature. There we see types of plant like conifers. In the polar subpolar region, temperate, not very cold, not very warm, tropical, warm. vegetation, neem tree. So equatorial region, so ample sunlight convection, temperature conducive for the growth. There is ample sunlight, ample moisture, so temperature conducive for the growth of the plants. So high moisture, ample sunlight, ample sunlight, high moisture, temperature conducive for the growth of the plant. Temperature does not change much, and second nutrient from the soil. Plants, when they will get required elements, we grow best when they will grow best vegetation. There will be different vegetation diversity. However, they produce maximum biomass. Different stage of their growth and shed tolerant. Shed tolerant plant will develop the ability to grow in shed. Ground vegetation will also grow due to diffuse sunlight. Okay, so diffuse sunlight, water in the soil, nutrient in the soil. Of course, water, nutrient, and diffuse sunlight. Some vegetation will also grow on the trunk of the trees and creepers. Buttress root trees require support to grow. Buttress trees are tall trees, shed tolerant trees. So buttress. Buttress is tall trees, shed tolerant trees, creepers, undergrowth leaves, broad leaves to absorb sunlight as much as possible. So buttress trees, tall trees, shed tolerant trees. That's for plants shed their leaves in due to reason. Water leaves to absorb sunlight as much as possible. Otherwise, the leaves drop to absorb sunlight as much as possible. And plants shed their leaves were to absorb sunlight of the water. Normal life cycle of the plants in the green forest minimize water loss from stomata, close out of the leaves. Reduce the load of snow. So reason for why plants shed their leaves. The plants shed their leaves because in order to store water, minimize the loss of the water to stomata. This happens in places where there is a scarcity of rainfall. Normal lifestyle of the plants. Evergreen forest minimize water loss and stomata, lower side of leaves, and reduce the load of the snow. So evergreen forest, the trees in the region have very hard trunk with the evergreen forest. This evergreen forest store biomass in the trunk. The trees are hardwood trees. The hardness is related to seeds. The trees in this region physically have much hard trunks. Ample moisture, but in season the biodiversity will be the ones which evolve should ensure that they store the energy only when moisture is available. The climate will relate the cycle is small optimum. Having a cycling growth seasons, season when they will regulate reduce loss of water in the season and get on. This will be the deciduous forest.